Hello and welcome back to the channel. In this video I'll be going over direct and inverse proportion. Sorry if my voice is a bit weird, I've got a runny nose. But anyway, let's get started. So I'll start by looking at what direct proportion actually is. So when two things are directly proportional, as one increases, the other increases at the same rate. So when you see two things that are directly proportional, you might be given it in this way. They say y is directly proportional to x. This symbol here means directly proportional. And it can also be written as y is equal to kx, where k is a constant. Now what that would look like on a graph is it would be a straight line graph, because it is a straight line equation, but there's no y-intercept, so the graph is always going to start at 0. Okay, let's look at some examples then of directly proportional stuff. So a car uses 50 litres of fuel to travel 600 kilometers. Calculate the amount of fuel the same car would need to travel 180 kilometers. So the way you'd go about doing this is, we know that y is equal to, let me get my black pen out. We know that y is equal to kx. So we've got to work out k because we're given y and x in the first part of the question. So let's say y is the distance and x is the litres of fuel. So 600 is equal to 50 k. So therefore k is equal to 600 divided by 50 is equal to 12. We can then work out the amount of fuel that the car would need to travel 180 kilometers, because we know what k is. So we know that the distance is y and the litres of fuel is x. So we can plug that in here. So 180, because that's the distance, is equal to 12x. So x is equal to 180 divided by 12, which is equal to 15. So our final answer is 15 litres. When working with direct proportion, it's very important that you use the same values that you plugged in originally. So you can't have the litres of fuel being y in the second part of the question. You have to make sure that whatever you put as y remains as y in the second part of the question. Whatever you put as x remains as x in the second part of the question. So have a look at the second question here at the bottom, and I'll go over it shortly. Okay, so the question says, if 15 wild lions can hunt 30 deer in 20 minutes, how many lions would be needed to hunt down 72 deer in 20 minutes? So I think the trick that this question is trying to get at is giving you 3 variables here, but the amount of time remains constant, so we're not working with that right now. We don't really care about the 20 minutes for this question. What we care about is the wild lions and the deer. So again, we'll say y is equal to kx, and then we'll say the number of deer is y, so 30 is equal to 15. Okay, so k is equal to 2, and in this case that would be 2 deer per line, right? So then we can plug that into our equation again if we want to work out the number of lions that we need. We said that the lions would be x, so again that would be 72 is equal to 2x, and therefore x would be equal to 36 lions as our final answer. Okay, let's look at inverse proportion now. So inverse proportion is the opposite of direct proportion. When two things are inversely proportional, as one increases, the other decreases at the same rate each time. So what that looks like is this. You'd be told that y, and then the exact same symbol, but this time is directly proportional to 1 over x, because 1 over x decreases as x increases. So it is directly proportional to 1 over x. And that can also be written as y is equal to k over x. So k is still a constant. And in this case here, you can see why x increases when y decreases, and vice versa. What that would look like on a graph is it would be a curve, kind of like this. This curve is a type of curve that we're going to look at more closely when we look at graphs in general. But for the time being, you just have to know that an inverse proportion graph would look like this. Okay. Let's have a look at some questions then. So, the first question says, it takes 4 cooks an hour to prepare a meal. Work out how long it would take 3 cooks to prepare the same meal. So, again, we're going to use our equation here. So y is equal to k over x. And let's say the number of cooks is y and the time is x. So 4 is equal to k over 1 hour here. So k is equal to 4. What does 4 mean? It means 4 cooks per hour, right? Each hour requires 4 cooks. So if we plug the same equation again, we can have 3 cooks here. That is equal to 4 over x, right? So 3x is equal to 4, and so x is equal to 4/3, which if we multiply by 60 gives us, put that into the calculator, 80. So our final answer is 80 minutes, or 1 hour and 20 minutes as our final answer. Okay, so this one's a bit more algebraic. If anything, I think this one would be a lot easier. So have a go at the bottom question here, and we'll go over it in a bit. Okay, so we're told that y is inversely proportional to x. And then we're told that when y is 47, x is equal to 8. Calculate the value of y when x is equal to 5. Okay, so very simply we just work out the value of k by multiplying 8 and 47. Put that into our calculator. 8 by 47 gives us 376. And then we're told we want to work out the value of y when x is equal to 5. So again, our equation here, y is equal to 376 over x. So y is equal to 376 over 5, which is equal to 75.2. And that is our final answer. Right. That is the end of the video. When you work with inverse and direct proportion, you just got to think about it logically. The two variables, do they increase with each other or do they decrease with each other? Like you might have the number of workers that are cleaning a house. Obviously, when the number of workers increases, then the amount of time taken to clean the house is going to decrease, so that would be inverse proportion. You just have to approach it logically. And yeah, that's the end of the video. If you have any questions, do drop them down below. I will be looking at all the comments, and that's the end of the video. I'll see you later.